Okay, well, I know that most of you are at some stage of being almost ready to start working with what we call the big model or the Illinois groundwater model. So I just thought I wanted to introduce you to some of the finer details of this monstrosity here. Devin, chime in whenever you want. Devin and I put this piece together about 2 years ago, maybe 3 years ago. It was months of calibrating on it, and tweaking, and we hijacked just about every computer in the area to get this thing calibrated. And it's had some marginal improvement since then.
Calibrated.
What's that?
Calibrated to the deep system.
Yeah, calibrated to the deep. There's really nothing in here. Well, there's a little bit of shallow calibration that was done for lower Illinois or middle Illinois region, but not much to speak of. Okay, so and ask questions whenever you want. So how many of you have used Vistas a little by now? Okay, so you're kind of roughly familiar, but okay, so what we're looking at here, I'm sure I'm talking, where's the speaker in this thing? I guess it doesn't matter.
You're fine.
Okay. What you're looking at is the first layer of this model. It has 26 layers to represent the geology of the state. So I'm going to do a couple things. We'll come back and talk about specifically what I'm doing. I just wanted to show you a cross section. This is what we're simulating. You're mainly seeing bedrock material here. Everything actually that's, I think below this gray anyway here is all bedrock material. So when we're talking Northeast Illinois, we're talking sandstone. We're talking the St. Peter sandstone and the Iron and Gellsville. When we talk about the Mount Simon, we have that in the model as well. We're not really doing anything with the density, the salinity, but that's what we have. We also have this, there are 9 layers depicting the shallow, unconsolidated material, just showing up as kind of greenish and grays, maybe some browns in here. Oh, I think we're actually looking at the Muhammad Aquifer. So there's a number of different colors right in through here as well. So that's our unconsolidated material. You're not going to see it very well in this model because it's all obscured. And the first thing about groundwater vistas that's very annoying is this is what you get. Wouldn't it be nice to say, I want to zoom in and look really closely up here? No, not getting it. You're just stuck with the entire extent in the cross section. So if you need to just look at glacial material, you might just have to blow away these other layers just within a different model just to visualize. But when we're working with the sandstone, this is good enough. So we'll talk a little more about what the layers are a little later. These hot buttons allow you to toggle what you're actually looking at. So this B lets you look at boundary conditions. Any boundary you're adding into the model, your river cells, your drain cells, no flow cells, all of those go in as a boundary. And the P is the property zone. So this is hydraulic connectivity that we're looking at. And you can see there were things that came up and then they're all overdrawn. Boundary conditions are drawing over. You can eliminate that. I'll show you how to do that. Or we could look at storage, or we could just go to layer 2
pretty sure the storage is roughly uniform across most layers. I mean, there's a couple of them, but
I think it is. I think it mainly is. Yeah, there's not a lot of creativity in the storage. But what you see here when we go down to layer 2, and this doesn't have any boundaries, no rivers, or imagine that there's no rivers in your layer 2. You'll see models that do it, but you're going to see here what looks like some things that kind of make sense geologically and some things that are like, wait, what am I looking at again? This is the Muhammad Aquifer domain. Very nice detailed mapping that's been done by the Geologic Survey. And the upper 9 layers represent that. So we'll keep going down and you'll see different geologic layers. There's a lot of time and effort over at the Geologic Survey into creating that.
you'll also notice this ugly pink overlay that keeps popping up. I believe that's where layers are being pinched out.
Yeah. Yeah, we'll get to that.
And that's why it's happening at these really shallow layers. And that's why we're seeing it over and over at these shallow layers.
Yeah.
Especially outside these refined mapping.
Right,
areas.
outside
Yeah.
the Muhammad or outside.
Actually, the Muhammad is based on mapping George did, but only for the upper 7 layers.
Right.
So that's why it's not there for layer 9. Layer 8 probably going to look similar. And then layer 7. There you can see the Muhammad. There's the wells with their names labeled in there. Middle Illinois was developed in using a different algorithm based on the percent sand thickness in each layer. So Middle Illinois, that's the part where we need to come up with a supply number for each county, some way. And you'll see that the wells are actually in there as we scroll down. I think they're mostly in layer 9. Yeah. Didn't really know where to put them. We can be a lot more sophisticated on how we do that. Just basically put them in the basal sand for lack of knowing anything else. But what you're going to find is getting pumpage into the model can get pretty complicated in terms of our aquifer codes. So if I zoom in, each one of these is a well. It's an analytic well. So if you ever hear me talk about analytic element modeling, nothing to do with this. It's just, Jim gave it a horrible name. He called it an analytic well. I don't know why he calls it that. It's not. It's just a regular well. But to access it, you click on Edit Analytic Elements. Otherwise, if I sit here and I try to double click on this, it's trying to change the connectivity zone. We'll talk about that later. But it's because P is selected here. We want to be able to actually edit a well. So if we double click on it, this is the well dialog box. It tells you the location of the well. In this case, the location is, it should be in Lambert X and Lambert Y coordinates, which is something that we use here at the Water Survey. Nobody else uses, but it helps our model stay in a nice square grid. We have to assign a top and a bottom to the model. Just general practice, it's good to try to get that in unconsolidated material and sand. Not have a top in clay, and definitely don't have a top in a pinched out layer. That will be no fun to try to troubleshoot.
It'll give you a completely useless, well, I don't even know
Is that the JJJ code?
Yeah.
JJJ,
It's
III,
the
plus,
the most
number
useless
sign.
mirror code ever.
yeah.
Your
Yeah.
model just crashed. And you're like, why is my model crashing? It's because you have a well and a pitched outlier. Congrats.
Okay, so we have our location, our three-dimensional geology, and then we also have to have our pumpage in the model. Well, we also have a name for it, which is taken from IWIP. So groundwater vistas, a few things you do not want your well name. You do not want a number sign. Like, what are some other symbols you don't want?
It just has problems with symbols in general.
Like, and
Yeah.
I don't even know how to draw an and sign. Somebody who knows how to draw an and sign.
The ampersand?
That's,
Yes, the other way.
is it?
Yeah.
That's wonderful. That's perfect. I'm not surprised I drew that backwards.
No, now you made me do it.
See? When's the last time you had to draw one of those physically? I always do that. So, anyway. Periods, commas, all kinds of things that show up in IWIP names repeatedly that it will not accept it if you try to import it.
Now, I know George hates having P numbers in there, at least. I personally use P numbers if I'm assigning names.
Moving forward, and the model's not that way right now, but this should always be our P number for each well. The reach number for a well should be the P number. What we like to do, two things, because when you're going through, it is nice if you're dealing with Joliet 1 through 30 to read Joliet 1 through 30 and not 409992. Wait, which one is that one again? So the way that moving forward, when we update pumpage in the model, we'll just have to remove that stuff. That's an easy thing in Python. And then assign the reach number as it comes into the model. Because what happens? What if this was Rock Island Trail State Park number 1 was the name in IWIP? I had to change it. Now my name is different than the name in IWIP. And that happens every time we build a model. It's easy to go through in Excel, okay, numbers were a problem. And then you go through and knock out all the number signs. But then that's all you do, and there's no way to tie your data back. You make all these modifications to it.
Not to mention names change.
And names change. So one of the things that I know, Vlad, you're aware of, I don't know how many other people are aware of, is we're going through writing a code in the database to update water use, but also model pumpage, so that we have a record through coding of names, reach numbers. Sometimes we have to change open intervals because the well isn't where the well's not in the basal sand, it's somewhere up higher, so on and so forth. I really should have. How many of you have seen the IWIP database? Really?
Twice.
I actually have access to
Which
it.
version?
Yeah, I do not think I have access to it here on this machine. And I really should call that up. Otherwise, this isn't going to make a lot of sense.
You probably don't have Groundwater. Or do you have Groundwater?
No, groundwater info's not on here.
Should be a copy on Polar. If you get on Polar.
What's that?
Should be a copy on Polar.
I don't think access is on here. I'm not sure. I'll just remote it. It's open on my.
Just so you know, Daniel, I'm only recording that screen.
That's fine.
Just so you know where to like
Mhm.
display stuff.
Mm-hmm. This must have restarted, so. Okay, as this opens up, we have a whole database. It's updated every year. So here's sort of modeling issue number one that we have is the pumpage that's in this model. We need to tie to our database so we don't have to go through and make the same exact changes every time we need to update 2018 pumpage in the model, like we have historically. So linking to the database is key to that. So as soon as that opens up, I'll bring that up. Okay, the other thing to note is that this box is checked off. The pumping rate is steady state. If that was checked on in the model, you would only have one pumpage rate for the entire simulation. But because this is checked off, we put our pumpage into transient data. And this model is set up that every stress period equals a year, and it starts in 1863. That's pre-development. So, in other words, 1863, 1864, so on and so forth. Anytime I ever wonder what a stress period is, I know that, and then I recalculate everything from that. File already in use. Oh, okay, whatever. Okay, and if we scroll down, a lot of stress periods in here. Wow, I'm glad we acknowledged this one in our model. This is in cubic feet per day. Our Joliet wells, for reference, are pumping about 133,000 cubic feet per day. This is what I call a small fry, and a lot of times we just kick these out of the model. We don't put domestic wells in either for the same reason. They're just not pumping enough. So
when you're importing wells into Vista, make sure you assign the negatives to all the pump values, otherwise you'll
Right.
put projection wells.
it's a quick fix though.
It is.
Jim has a quick fix for that one because that's such a common error. You can do math on everything and just multiply everything by -1. Oh, here we go. So where this comes from then is our database. This is our IWIP database. You all should have access to this. So
Yeah, technically this is,
yeah, well, this is the front for the IWIP database. These tables are all making up the database, tables and queries and whatnot. It's a SQL database. And quite frankly, if we can get away from using Access and just tie right into Python and look at this, all the better. So yeah, this isn't where I thought. I'm unscripted here, so who knows where this is going to go. But this table is, or this access, what do we call this then, Devin?
well, it's the table.
This access, this table. But what is this this combination of all of them? It's the database, right?
Yeah, sort of. Close enough.
I mean,
Access is just.
it's not stored in Access. I think that's the key.
It's
here.
just a GUI basically.
Yeah.
For your
Yeah.
database. So.
There's a connection here. So what you'll have to do is set up, after you have Access installed, which you probably already do, then you'll have to set up one of these ODBC database connections so you can visualize everything. You can also use GWinfo, but no, you can't do large scale analyses with it. So we'll need to get all of you set up with this. It's just view only. You can't hurt it. I've not been able to hurt it yet.
Generally speaking, nobody has permission to delete or modify the data tables themselves. Hopefully. So
Yeah. Who does have it? Who is the master who can do that? Greg?
You can do GWinfo, but can't do mass updates anymore.
Ah, okay.
no GTF.
But it's moving electronic, so you know. Okay, so what matters here is the points. And here you can already see some of these names have dots and who knows what else hidden in here. Where's the, oh, it's over there. But one, you can look at, let's say, just Joliet.
No, this is the points table.
Yeah, that's where I wanted to be. I wanted to show a couple things in this before getting into pumpage. So this shows all of the wells owned by Joliet through time. And this is our P number. So again, when we're dealing with a well, we should always somehow have some flag to the P number. This is our unique identifier. Joliet 1, Joliet 30, that's not necessarily a unique identifier. But the P number is.
So it's an in-house thing?
Yes.
Yes.
And the water survey has their own variant, or sorry, the geologic survey has their own version of the P number. But it's different, and there's no match between our P numbers and their API numbers.
Well, there's not a complete match, we'll say.
There's not. So if it's not a complete match, then yeah. There have been some efforts to try to get those updated, but
this is going to require a lot of manual work.
yeah.
If the two databases are maintained independently and the records don't match.
Yeah.
So.
But if it's going to require a lot of manual work, that's as good as saying it's never going to happen. I wouldn't count on it. We've been talking for 6 years about combining them. And we're as close today as we were 6 years ago. We're probably farther than we were 6 years ago. So don't hold your breath on that. But the Geologic Survey database has a lot of information, as does this. It's not the best structured here, this point table. But it shows you where the wells are located. Sometimes it gives you well site information. If there's a previous owner, you might get that information.
Generally, if you're looking after, well, obviously if you're looking out for any of the geology stuff, definitely go to the Geological Survey database because we don't really have that here. But for most of the things, our records in theory more current because we do update these versus the GeoSurvey database in most cases doesn't update theirs.
Yeah. These are the coordinates that we use for the model, Lambert X and Lambert Y. If you use those outside of the water survey, people are just going to give you a look like, what is this? But that's what we update and what we use in the model. There's also a lat long that's not consistently updated. And if you're all to take a guess, if you converted that lat long to Lambert XY, you think they'd match?
Well, for a fact they don't.
You're spoiling it. You know the answer. That question was not for you. They do not. And so which one's more accurate? I think it depends. So Location is tricky.
How drastically different are they?
It depends. Sometimes someone's gone out and surveyed them, but then there was this whole period of time where the EPA and us couldn't decide which version had the better location data. So at times the EPA took our location over theirs, and then we did the same. And so there's been multiple versions of overriding each other's location data. So
Yeah. Oh, let's see. So we have an elevation, land surface. Again,
I would not trust that. I mean,
there's a
sometimes
lot of 565s here. And you see that, that's always suspicious.
a lot of them are taken right off topo maps.
Yeah.
So.
But a lot of times this is all we have. So it's better than nothing, at least for the sandstone. Remember with the sandstone, we're talking 1,000-foot water levels if you're off 5 foot. Who cares? We're not that accurate. But if you're talking shallow aquifer, and you're off a foot, that can make a big difference. Aquifer code is another big one. So every well is assigned an aquifer code. Sometimes, well, not every, as you see. Sometimes it's just 0101. That means that it's an unconsolidated aquifer, quaternary, generally, and just slap on 0101. We're not assigning specific numbers. So if it's a Mahomet aquifer sand, it'll get a 0101. It won't get a code for the Mahomet aquifer. The rest of these, though, actually have meaning. And in the big orange book, in the appendix, the one right behind Devin there, in the appendix, there's an aquifer code for everything. And 66, I believe, is the St. Peter. 93, I believe, is the Eau Claire. 87 is the Ironton-Gellsville. So you can look all those up, but some of these are Silurian wells. 5656 is Silurian dolomite. So you can go through that. The first two numbers tell you the first unit, the first aquifer unit the well is open to, and the last two tell you the last. So what you're going to notice here is that there's a lot of wells that go through multiple units, and in the sandstone, that used to be the way most wells are drilled. Anything 66, 97, St. Peter, Eau Claire, St. Peter, Ironton-Gellsville. But more recently, we get 8193, casing through the St. Peter and casing off the St. Peter and leaving just the Ironton-Gellsville open. But we need to make use of this as well when a new well comes in. Now,
mainly because the open interval data is sparsely populated. So.
Yeah. So like this well, what is this? This is not labeled. These are not labeled. The other information that's in here is a total depth. So, you know, that's a shallow well, but sometimes you'll get, there we go. It's a sandstone well. It says Ironton-Gellsville, but is it open to the St. Peter? That information isn't necessarily here, but if we keep scrolling over,
No, it actually does that.
yeah, you'll see that the casing goes to 1,100 feet. The St. Peter is probably higher than that, so it's actually casing off. So this should get like an 87, or some code similar to that to say this is an Ironton-Gellsville only well. I should draw this. Okay, so this is Mount Simon. that's a 97. Ironton Gillsville, I think, is 87. St. Peter, I think, is 66. And so if you have a code that says 83 to 93, let's see, this is the Eau Claire. This is Prairie du Chien, Tosi, Eminence, Franconia, bunch of garbage. So in 83, 93, you know your well is open, something like this, and it's cased off up through here. 66, 87 would be something like that. So the reason I'm bringing this up is that we have wells already in the model. That was silly. Let me go to the sandstone. I think that's layer 18 is the Ironton Gillsville. Yeah. Ah. You can see these are given P number names. So I would have something to reference back to here, but let's see. So when we were in Joliet and the two wells that we're talking about that are south of the fault, those are located here. This is where they want to drill a couple of new wells, but we double click on one of these, you'll see this is 1818. That's a what we call an Ironton Gillsville only well. That would have either an 8393 or an 8787, some code like that, that we've assigned. Whereas if I go maybe here, yeah, this is a 1518. Layer 15 in our model is the St. Peter. Layer 18 is the Ironton Gillsville. So this well would have an aquifer code of something like 6687. And this has all been done. There's P numbers here, but I'm hopeful that we just kind of start a new script and just get all this updated in a very streamlined fashion. So somewhere we need some kind of translation or some rules to say 6687, what have you. The other layer to this, as Devin was saying, is that we sometimes don't have an aquifer code. So there's something called geogoy that Devin came up with. He spelled geology, and it was easier just to call it geogoy. It compares all of our model layers to the open interval and basically does this comparison to where instead of an aquifer code, let's say this is land surface. Obviously that's kind of a jump there, but let's say the well depth was 1,000 feet. Then we have a model depth of the Ironton Gillsville top and bottom, and we use that to determine our aquifer code. Rather, that's when it's missing.
It's a little more nuanced than that. Part of the reason it needs recreated because it really needs coded up. Because you'll find that most of the time we're actually missing open interval data for the wells.
Yep.
So what it does is it looks at surrounding wells and their completion dates and the trends in the completions at the time, and uses that as the open interval.
Yeah. Yeah, that's the other, the next step when you don't have the open interval information to add.
Because the well construction trends are pretty consistent over time. They follow pretty regular trends. Kind of extrapolate where you don't have data.
So that's all hear me talk about Enigma and linking the model to IWIP, this is what I'm getting at, is tying the updates in the model so we can, boom, hit a button and update all of this stuff, rather than going through all the tedious steps that we always have in the past. But, you know, GeoGOI is still kind of tedious. It's not really made to where we can easily do an update.
Yeah, well, yoga is not something we should hopefully have to run very often, but
Yeah.
it should be quite a bit.
I'd say we probably have to run it every time we do every time new wells come in. We just don't know.
It every time.
Yeah. So that's kind of an annual update, if you will, to the model whenever the IWIP state is ready.
Most wherever we get better geology.
Yeah. So, okay, so in this area, at least for the sandstone, I'm using P numbers. So you'll be able to look in the database and easily tell which one is which, but at least for Will County, we probably want to go through and update these to get meaningful names, and make sure the reach number is the P number, which I don't think it is in this case. No, it's not. Okay. That's pumpage. The other thing that we want to do with the model is we're using the standard well package, which means we're doing some weird things in the model, which we'll talk about shortly. But we don't want to do that. We want to do this in a more realistic way. So what we want, if a well comes in or a well gets sealed and it's providing a connection between St. Peter and Iron Gelsville, that's creating a pathway for flow. We want that to be able to come in and to block out. To do that, we need to make this a multi-node well, or actually we're using unstructured grid, so a CLN well. And that's going to add computation time to everything, but it allows us to set some other properties here. Dan played around with CLN with his fault zone study, and so I think he has the properties that have worked in the past to make the model run. So we can lean on his ear a bit whenever that time comes, but this allows us to simulate these connections and to have them go in and go out. And that's that's important, having them come in at a particular time, go out at a particular time.
I will say that's another thing I will need addressing when we get to that point, because you'll find that I think it's like over 50% of the industrial wells don't have a completion date in the database, so we're gonna have to make some assumptions about when wells come in and when they go out, because there's a lot of wells that are abandoned, we may or may not technically still be there. So.
Yeah, and some of these wells kind of self-clog through time, it seems. So this is discussed a little bit in the report, and I would also recommend that you look at Devon's hydrologic process paper, because it lays the foundation for some of this. I think it does anyway. Yeah, it does. It does.
I mean, at some point, I haven't never gotten to this point, but we've seen how the joy and calibration may be deviating. Might be just a matter of tweaking the sealing factor, so to speak, of these wells to see how many we should be kicking out.
So here's the weird thing we do. I don't even know that I want to talk about this.
Yeah.
Just because we want to get away from it. But just to let you know, what you see here is sort of a pattern of where connections are present. And so if I scroll the mouse over, and I have hydraulic connectivity, you're looking at hydraulic connectivity, it's checked on. And if you look down in the corner, you'll see that the vertical conductivity is 6.8 e to the minus 6. And if I go to one of these brown cells, it's still 6.8 e to the minus 6. And one of the green ones, it's still 6.8 e to the minus 6. They're different zone numbers. This is zone 25, zone 28, zone 7. Okay, great, but what's changing? We're using something called time variant material, the TVM package. And so you're not going to find this in any tutorial. That is
Yes.
an unstructured grid only option. I'm probably getting way ahead of where I should be right now because we haven't even talked about option menus yet. But it's just to show you, it's something that we click on here at TVM. We're allocating memory and we're using up to 70 zones here. And some of these, there's details to this. I'm not going to get into it. But if we go to model unstructured grid, time variant material spreadsheet, and I just scroll down through here, you're going to notice that zone 1 is always 1, never deviates. What this is a multiplier to the vertical conductivity that's tied to a stress period. And so, okay, it basically means nothing's active there. But if I go to zone 7, which is one that we saw, now suddenly, starting in stress period 38, there's a big multiplier here, 3.2 e to the minus 4. That's multiplying that 6.8 e to the minus 6 to give us a larger vertical conductivity that's basically faking the impact of adding in a multi-aquifer well that wasn't in there originally. So this anthropogenic impact that's added in. Then I think the other one was 28, maybe. We go to zone 28, same thing. And that starts at stress period 38. I actually think 7 starts at stress period 38 too.
Yeah, I think the others are like 56 or something.
Yeah. But you can control when it comes in and when it goes out. Oh, that's the difference. This one goes out in stress period 116. Whereas 28 never goes out. Those are connections that we still think are there versus those first. Devin mentioned all these old industrial wells. We think they're sealed. We have no record of it. When we tried to calibrate the model, it was providing way too much water exchange between the two. So we cut them out at some point in time. So this allows us to bring connections in and out. But basically, it's a big cheat here to get our model calibrated by bringing in connections, starting in about 1900, taking them out in 1960. Some of them, but leaving others in. And there's some rhyme or reason to how we did it, but it's not.
Read my paper.
Yeah.
So they're coordinated to specific wells there.
Yeah. Yeah, and so you actually do see here where at least some of these wells.
You go up to layer 15 or 14, actually, you'll see a lot more
Yeah.
elsewhere too.
Yeah.
What's the element size?
What's that?
What's the element size?
Oh, the model grid is 2,500. So you see here a model cell, 2,500 feet on a side. And here's our Will County area. So just to kind of put it in perspective, this is Romeoville up here, I think. This is Joliet here. This is Flint Hills. No, that's not right. This is Flint Hills down here. This is the fault zone. which is also treated a little separately. And kind of wackily, I guess. Not really perfect how we do it, but yeah. This is a conceptualization based off the old Arsenal study. So this would be Flint Hills. This is the Arsenal. Here's Exxon. So this is Joliet up here. Yeah, and that one up there was Romeoville. So those are that's Lockport, where I assume that there are going to be some new Lockport wells. Anything that is 400003, those are wells that I added in when I was doing future scenarios. So we added in 2 Joliet wells within the fault zone here. A Joliet well somewhere in the center of town. There we go. That's actually Crest Hill there. And then some Joliet wells or new sandstone wells in Lockport. So that's one of the reasons we made the whole trip last week, was to figure out who's drilling where, who's adding wells in what location. Okay. So if I keep scrolling up here, this is the St. Peter. You're going to see there's still some wells, but it's a lot fewer. These are wells that penetrate into the Galena Platteville, which is what this orange layer represents. These are, again, TVM zones. This is the Macocata Shell and some of the bypass in the Joliet area to let a little water in. So we talked about how water can't make its way down, but if you have a St. Peter well that's connected, that's open through the Macocata Shell to a significant portion, that's the source of water. And there's the Silurian, and here's where it's pinching out. So this is why Joliet's not using Silurian over here. We're getting close to the edge of pinching out in Lockport, Crest Hill, on that area. Questions on pumping? Let me walk you through the layers in the model. If this ever annoys you where boundary conditions are being written, you can just turn off boundary conditions. And I did that through the plot menu. Plot, oops. What to display. You can toggle on or off boundary conditions. If you click boundary condition and you want to look at something specific, you can still do that. So if I want to look at just constant heads,
you'll notice that
I can click that on, and there's where we have constant heads in our model. But that's the only thing you see at this point in time. And if I just wanted to look at rivers or drains, I can go river, view, refresh, or control R. And here's where our river cells are. I don't have different colors in here. Sorry, Devin, what were you saying?
Oh, no, I just got to point out that you see how Iowa's currently a bunch of no-flow cells. We're fixing that.
Yep. So over in Iowa, we just assume that there's no flow or anything happening over here. It works okay when we're out here. It works okay for Middle Illinois, but by the time we get out here, no. There's actually. Have you heard anything from him?
Not recently, although.
Okay.
Basically, they have a big pumping center over there that's influencing Illinois.
Quad Cities or?
I think roughly that area, but there's a bunch of ethanol production plants.
Okay, so I mentioned this earlier, but in this model, you're going to see 3 quaternary geology depictions. There's a very crude one that I came up with that used major sand and gravel aquifers and stack maps. I'm not even going to go into the details of it. We want to replace it. And now we have the ability to replace that throughout the entire state, based on new work that the geologic study has done. So that just to say, Green River lowlands, we don't want to use what's in this model. We want to actually recreate that. Middle Illinois, we can go ahead and use what's in here because it's using that same methodology that's now done for the rest of the state. So the other thing I should point out, zone-wise, you can scroll through here. You're looking at all the hydraulic connectivity zones. You can go to props, property values, database. Here's where all our zones are defined. And you can change colors. And, you know, if I want to make this something that'll make Dan angry, make it hot pink, and you know, you can change your colors there and what have you.
Is there a limit to the number of zones you can have?
No, not that I'm aware of.
Practically speaking, there probably is, but it's a matter of how unstable you can make it.
Yeah. I don't know why it would really matter though.
I don't think it would.
You can also go cell by cell conductivity.
No, that's true.
You don't have to have, and I've done that before. I've accidentally converted a model that cell by cell conductivity into zones, and I got a ridiculous number of zones. It did fine. So,
Are there input files that say I don't want to use this GUI, I just want to go to some .dat file and mess around in there and have it be reflected back in the Groundwater vistas?
yeah, you weren't here when we talked about input and output files,
Okay,
but
I can ask.
there are. No, let's do it again because I'm sure everybody remembers all those. I'm gonna have to sit here and think where they're at.
Good time for me to leave the class.
They gotta go to class?
I mean, technically, I should go to class, you think?
Who is it, Jimmy?
No, it's Megan's class.
You should go to Megan's class. If it was Jimmy, I'd say so.
I'd go up there, yeah.
Yeah. Thanks, Devin. We'll follow up. Oh, where is the model? So when you get a model, and actually this is true. So I'm going to talk a little more about this, but honestly, I can sit here and rattle on, and you're all just going to get incredibly bored and have no idea what I'm talking about. So I think the best thing is to play with the model. And so one of the things you're going to need to do is when you copy over the model, you're going to need to go to paths of models. And the working directory is where all the files are located. So if I hit browse, oops, well, let's just see. It's on my desktop, the best place to put things. Update, up-to-date model. That's a name that'll stand the test of time. Up-to-date model. These are all of your input and all of your output files. And so what you do when you have everything in the GUI and it's all developed, you have this working directory, you can hit recalculate, and that'll write all your files, it'll run the model and create your output files. It'll write your inputs, it'll write all the inputs. By that, all this conductivity, the stuff that you want to see in a DAT file, you don't want to see in a GUI. You're anti-GUI. You're anti-paying $4,000 for this thing. Then you can either hit that, or you can also go model. You have to go to unstructured grid. This is an unstructured grid, and I should walk you through. I'm doing all this backwards. I'm sorry. But you can go to create data sets. That's going to write everything here into the DAT files that you're after. And so we go here, you're going to see that includes a base file. That's the basic file. And this contains, I never even bothered to memorize it. It contains something about the model. When I showed this the other day, it was on the East St. Louis model, and this is all, the East St. Louis model is really easy to work with because it's small. This model is enormous, and you're going to have to get used to when you dive into the files looking at things like this one. Okay, when are you going to open up? And I don't even want to bother with it, but so that's an input. The CVB is an output file. The one I do want to show you is the name file. So these are all the different files that are written or created. The list file contains both input and output information. It's updated throughout the simulation. You ever troubleshooting a model, go there. The base file contains basic information about your model. I wish I could tell you what that is. SMS is the solver file. We had PCG last time with East St. Louis. This is the unstructured grid solver file. We have a discretization file, output control, TVM, all that stuff I was just talking about with these vertical conductivity changes are controlled with the TVM file. Recharge, the well file, the river file, drain, constant head, LPF. This is Georgia's special version, hence the name. And then the output files are the CVB, and there should be a head file here. Yeah, these are all output files that are written. They're all in binary. They have to write a code to read the binary files or read them into Flowpie. It does that for you. But if you're ever wondering where that's all going, go to model, paths to models, and that'll show you where everything is. So I'm going to recommend that when we're done here, I'm going to give you all access to this so you can copy this over onto your own machines and start going around like what. I'm going to recommend that you all run it tonight. Just to see the inputs and outputs and everything. So
How big is this?
it's big. Don't copy over the CBB file. Big. CBB file is 37 gigabytes. And I didn't run it to completion.
When you recommend that we run it tonight? When you recommend that we run it tonight?
Or sometime this week.
Won't we be generating that?
The CBB, you will.
Yeah.
I'm just going to recommend when you copy it over to run it,
Don't
that
worry.
you don't.
Okay.
That you don't worry about it. Because what I want to show you are inputs and outputs, but it's kind of better explored on your own, or maybe give you all a day to look at this, and then on Wednesday, after George runs through his bill, maybe in October, but maybe in Germany right now. I don't know. That he might be. So, but like, yeah, probably won't go. Probably maybe will. But I recommend that you just kind of play around with it and see the inputs and outputs and whatnot. But at least you and Cecilia and probably you, Alan, because this is the model that we'll use for the yeah. And then just on Wednesday we can sit down and talk about specifics on it. Let's see. So I can run through the layers, but I mean, we already kind of did that. You'll just see different connectivity, different collars. Devin pointed out this pink, that means that a layer is being pinched out. George talked about this briefly.
You mean the purple that's like over everywhere, or the pink that's in the middle of them?
Not the middle of Illinois region, but everything like
Yeah.
reaching up into Wisconsin, whatever
Okay.
color. you
Yeah,
put in Indiana,
what's
Michigan,
covering
whatever
most
color.
of the area here. And it means this layer is not present. So you may have a layer 1, layer 2, and layer 3. An unstructured grid lets you say, blow that out of the computation. And so you could
Keep going.
So the,
hello there for anybody suffering through this in the future.
Nobody is.
the
Future
layer,
people suffering through this.
the layer that's pinched out, that's represented by the pink right now, is that the brown?
No, it's actually, that's an interesting point. The way the model's set up, layer 1 shouldn't ever be pinched out. Make a liar out of me. There's no pinched out layers in layer 1. Actually, you can run into a lot of computational nonsense if you do that. There we go. There, just get you all on board and say hello to future Dan when I make him watch this for not showing up. His punishment for not showing up.
Mostly pointing the webcam at the board so you can catch what everything.
That's actually the best place to point it, isn't it? Yeah. Okay. There we go. So yeah, it's not pinched out. I wish there was you can't really see it here, but let me give you a cross section. Row 220, I think will be a good one to see this. Yeah. You can see here where all these layers just are not present. This is what we call Pennsylvania, Mississippian, Upper Devonian PMUD. And that's all being pinched out as we move up where Silurian's at land surface, which there's no Pennsylvania, Mississippian, Upper Devonian in Lockport or those areas. So this is why we have such permeable. Although I think this is Lockport and Crest Hill area. And this brighter green means that the Silurian's at the bedrock surface. Notice we didn't make it bright green here, where we think it's less permeable. George will talk one day about why he thinks that. But the other thing that's going on is there's sand overlying the Silurian here. So that's another thing that's adding to the permeability of the sand, the basal sand there. So this blue is sand, the brown is till. But this one shows how layers are really pinching out, getting thin. And that makes a big difference then when we're.
So the Pennsylvania Mississippian is represented by that purple pink.
Yes,
Look at the, okay.
exactly. So yeah, let's actually go to the Pennsylvanian layer then.
But not always. So it depends on
Yep.
what layer you're looking at. So when we get to the Pennsylvania or PMUD layers,
Yeah.
you will see expansive pink or purple, whatever, pinch out. But these upper layers here, these layers 3, 4, 2, 3, 4 that he's just gone through, do not represent the PMUD layers.
Right.
Those layers also just happen to be pinching out. In the zone. Okay.
Yeah, the quaternary, because there's 3 levels of mapping. There's the mapping that was done out here, which is very crude. There's the mapping done for Middle Illinois, which is much more refined. And then the Muhammad Aquifer, which is your traditional mapping out geologic units. It would be like mapping out the St. Cody and the Tampico explicitly, like what Larson did. And I think Larson did a lot of this down here as well. It was what George was talking about last time when he was talking about the Muhammad, all the different mapping and work that went into that. And most of the pumping is in the Muhammad, and that's layer 7. Okay, so I go down to layer 10. Layer 10, we're out of the quaternary. And I'm actually a little surprised, except up to here to see. I guess I'm not really sure what's going on there. Oh, I know. It's a detail that I want actually out of the model when we do the next generation of the model. It's a sort of a residual of trying to get the model to work before we could pinch layers out, because we adopted midway. But you'll see most of it, it's not pinched out. But what you see, anything green is the Silurian, and right in here is those are our Silurian users. Anything in gray down here is Pennsylvania, Mississippian, Upper Devonian. This is Macokota, a lot of different colors because we've tried a lot of different things to get enough water in through the Macokota. Orange is the Galena Platteville. Here's where the St. Peter is at land surface in Illinois and running through some of these bedrock valleys, and you're not going to see it very well because it's almost the same color, but there's some Ironton Gelsville at land surface up here. It's a slightly different shade.
What color is the St. Peter?
It's this bluish,
Okay.
purplish,
Got
lavenderish color.
Very well color up there.
And then if we go to layer, so what you're looking at is what we call the shallow bedrock layer in the model. And this is different from everything else because it's not one geology. It's about a 50, 100 foot thick layer that we assign, and we give different properties to it than we give the deeper bedrock, because this is what we consider our weathered bedrock. And so the general rule of thumb is the upper 50 to 100 feet of the bedrock is more permeable than anything lower. Kind of makes sense. So that's what we're depicting here in the model. And then everything below that is a geologic unit that's not within that upper 100 feet of the bedrock surface. So that's how we're modeling this. Just to kind of be clear. Most of our models model layers deeper go like this, but our upper bedrock layer is a uniform thickness. I think it's 100 feet, except for places here where the river's really in, I don't know what happened there. It's a weird interpolation thing or some change that we made somewhere along the way. But for the most part, this is about 100 feet thick. And so if this is, let's say, Silurian Devonian, this is weathered Silurian Devonian. And then if this is Macokota, this is weathered Macokota. And if this is Galena Platte, this is weathered Galena Platte. And then we have to make some sort of cutoff here because it's just a uniform, it's a cell thickness as you go down over that 100 feet. And where we cut this off actually does matter for local scale analyses. So we may want to revisit how that's done, but this is the structure of our model. And so this is layer 10. This is layer actually 12, because this is pea mud up here. Pea mud is layer 11. Layer 13, layer 14, yeah, this is right. And then we get the St. Peter. That is layer 15. So what you're going to see then as we walk down in layer 11, this is the Pennsylvanian Mississippian layer. And so everywhere that's not present, that's where you see pink. And then you go down to layer 12. This is Silurian. Everywhere it's not present, that's where you see pink. 13 is the Macocata. Same thing, everywhere it's not present, you see pink, it's pinched out. 14, Galena Platteville. And then 15, St. Peter. You'll see a lot of weird remnants of the model interpolation up here throughout. So if you ever see something and you're like, wait, what am I looking at? Or sometimes we'll rezone things and it's not been properly accounted for, like I noticed here. No, one layer up. There's this weird little patch of Silurian here, so that's, I don't quite know what happened there. So there's a couple of weird little remnants in here that it's because the model went through so many different iterations when this was being developed before we switched on structured grid. But it's, for the most part, capturing what we needed to.
So the blue text is the little P numbers?
Yeah, the blue, these are all the wells. And if you ever don't want to see that, you can always turn that off. And here, display options where it says display analytic wells,
Yes.
just click that off.
Okay, great.
And that way, boom, you don't have to bother with looking at those.
To clarify on what Cecilia just asked, what's displayed there are the names, the well names, right?
Yeah.
Not the well P numbers.
Well, it depends. For the
Sometimes-
bedrock, it's P numbers.
Okay.
For the shallow, it's the IWIP name
Okay.
with that crap kicking out.
Okay.
Isn't that great? One model with two inconsistent ways of doing it. You can see how the model's been pieced together. And honestly, why we're really in need of a way to do this more structured, because weird things happen when you don't do it in a structured way. And I do one thing and George does one thing. Or to be blunt, I do something and then me 2 months into the future does something. I'm not going to do it the same way necessarily when I bring that information in.
Okay. Sure. But going unified, having scripts would help to unify.
Having scripts so that that's all taken care of. So I'm not thinking about it. It shouldn't even be something I'm thinking about when I'm trying to update pumpage in the model. In the long term.
Right. In
Because
20 years, we
that's-
finally get it all working.
Yeah, that's a lot of the work is getting a script. So even just having a script to do it is a big key here. Okay. I should show you a few things from the menu, but let's see. We've gone an hour and 15 minutes. How long before this gets like
Well,
spare
whatever.
us?
I mean, to some extent, your goal was to just get us introduced to the model and then have us start playing and then have come back with questions on Wednesday.
Yeah.
So take maybe 10 minutes and say, what are some problems that you expect us to run into so that we can troubleshoot on our own? And then we're not all coming with the same, like, oh, this one thing didn't work because, but otherwise, I think you've given us enough to start poking around. At least
Yeah.
I think that. If anybody else disagrees, please feel free to speak up.
One more thing I want to show you is, and then I think we'll just get it set up to where you guys can take this independently and get it, because I want to save enough time so that you'll hopefully have a chance to get this set up on your machines and hit run tonight and have something to look at tomorrow.
Sure.
and that'll take a little while.
Do we have enough licenses for that?
What's that?
Do we have enough licenses for that?
Devin's in class, Dan's in class, so yeah. We'll make it work. For sure. You already have one license between the two of you, right? Or do you have two?
I think it's just the one.
Yeah, well, Devin gave me one.
Okay, Devin probably gave you his.
Yeah.
Did you already have one, or do
I
you?
still have one.
Hmm?
Well, actually, Cal gave it.
Okay, so you'll need a key then. Yeah.
Yep.
Okay, that's my key.
Do you want it?
I don't know.
I'll write it for it.
Yeah, and then technically, once we get it running, we can actually. You don't need the key at that point, but yeah. Okay, I want to show you a couple of other things. One is the stress period setup, and one is the solver settings. When you're dealing with a model, we're dealing with unstructured grid. So you go model. Some of the settings are in MODFLOW, and some of them are in MODFLOW unstructured grid. I don't know why it's set up that way. So if you go to package options, this is basically your settings for MODFLOW. Model, MODFLOW, package options. And you can control the number of stress periods. You can set up a steady state simulation if you want. We do not want that. We want stress periods. And then we're simulating a subset 1 to 143, which is why my import failed. I tried to import 198, but I've only run part of it. So there's some other settings here. One that we should never check, and you'll notice it's checked, is continue the simulation even if convergence is not achieved. If your model didn't converge, maybe it got close enough, and you can just let it go. But if you're doing contaminant transport or something, it really needs to converge on your parameters that you've set. So that's a big cheat. I know GMS is going to have that as well.
Just keep it unchecked.
Yeah, it should be unchecked, and your model should, your mass balance should be converging. Only because we've looked at this model enough, we're confident that if it doesn't converge, we're okay. And it's really challenging on a model this scale to get it to converge. But with a simpler model, this should not be checked. So you can set some things up there like the stress period number. And then, yeah, that's fine. You can also go to stress period setup. And this allows you to assign the length. So the first stress period runs for 36,000 days. Anytime you're dealing with vistas, you don't have to worry about units as long as you're consistent throughout. So if you have days, make sure everything's in days. And everything here is in days. So
yeah, what are your units in general? Feet,
feet and days.
That's it?
Yep. Okay. Yep. Cubic feet per day. Yep. And so I'm running this basically for 100 years, or wait, yeah, 100 years. And I'm forcing it to steady state because I can't run a steady. Normally, your first stress period should always be steady state. But I can't do that in this case because I'm using the TVM package, which doesn't, it's once transient every stress period. I don't know why. So that's really frustrating. But we want to get away from TVM. So generally, it doesn't matter what you set this at. If it's steady state, running a steady state simulation. Time's not a factor. But everything else is transient, and so we're just running 1 year here. The other thing, and this is where Vistus is a little confusing, I'll admit, you go to MODFLOW stress period setup to determine your time interval at each stress period. So if you want 1 day stress period, that's how you set that up. But then if you also have to go to MODFLOW 2000 and go to stress period type. This is where you determine the type of model that you're, is it a steady state or transient stress period? And so 1 means transient, 0 would be steady state. So everything here is transient.
So what are the stress periods supposed to model, like seasonal variations in groundwater demand, or?
It's annual. So by 365, I'm saying 365 days for each stress period. And for the pumpage, then we're changing pumpage. So I'll show you what we're not doing well, that's all you have to do here. What we're not doing, and this is not going to work, at least in East St. Louis, it's not going to work if we're trying to answer a question about the dragonfly. We need a transient simulation, but if we go to our streams, double click, you're going to notice they're all set at steady state boundaries. We never change our stream. We just pull it off the DEM, and that's that. And that works for the sandstone because it's deep. It doesn't really, you can change the stream a little bit. Not going to make a big difference. But if we uncheck that, then we have the capability of assigning a stage and a vertical conductance and a width. So if we want the stream to go up and down, the Illinois River is a good example. It's gone up, flow's gone up, effluent from Chicago coming down. So the stage is going up in the Illinois River through time. We're not simulating. And then we go and actually look at the Muhammad Aquifer. You can't really simulate it right because there's a 20-foot difference, 10-foot difference in the stage. I can't remember what it is, but it's enough that you're going to see it when you try to simulate it in a groundwater flow model. Problem is, we have some gauges, but how in the world do you handle a headwater stream? How do you let that change? How do you make that transient? That's a big question that we're all going to have to sit down and figure out. How do you deploy a model that accounts for gauges all throughout, and yet so okay, the Illinois River, right here, that's changed maybe 10, 15 feet through time, gone up. But what about this little guy right here? How is that changed? You know, it doesn't do me any good if I'm only simulating half of the streams. That's transient, but these aren't ungauged. Hence why everything's in their steady state. It's not that we're being lazy, it's just we don't really know how to do it any other way. But it's important. So East St. Louis, it's going to be important to get the transient boundaries in. I would argue same thing at Lockport with the Des Plaines River, getting that going up and down properly. So we take whatever gauge data we have, but we're going to make some big assumptions.
It's not very well gauged. Right?
Yeah. The Rock River, you know, for Green River lowlands, do we need to account for the transients in that, or the Green River itself? Maybe that's not as well connected in places, but where it is.
For the St. Coda, we don't know if Temp Coda will be big.
Yeah. So exactly. And so can you get away with steady state when you're simulating, if all you care about is the same coding, and you can get away with not worrying about the Temp Coda? But can you get away with that? That's a big question. And we've missed it time and again where our models fail to capture transient seasonal changes in streams. A stream may be recharging and then discharging in another part of the season. And I know George thinks that in the Muhammad Aquifer. So that's a big question here that we're going to have to capture. So just keeping in mind, this is a big transient model. And so for Will County, what we need to do before the next meeting, and I have a this model should suffice for being able to do that, is to add in a couple of stress periods and put in pumpage that communities have been reporting monthly, and just go through and compare. So add in a couple of 30-day stress periods. And we can start on the technicals of doing that tomorrow. That's not too big of a deal. But longer term, tying in the data as we get monthly data reported and appending that to the model and running it before each of the meetings, that kind of stuff is the other goal there. But I think before we worry about any of that, let's just get the model running
Right.
first.
Yeah, so for getting that model running, are there any other small tips you want to give? Otherwise,
Yeah. Couple more things. Go to package options, initial heads. Okay. We're using the top of layer 1 as our starting head. That's always a nice way to start because you're just pulling it out of the model. Sometimes we will grab our initial heads from an actual file, the head save, or this set heads from a head save file. And we will need to point this to a specific file. And you'll have to modify your directory when you fire it up. We're not doing that now because when we make changes to the model, this was very sensitive to changes, so it had to be frequently updated. But the update is just simply to run a steady state model. We can mimic that by running a 100-year model. That's why that first stress period is so long. But to be honest, we could probably stand to add a couple more zeros to that to run it to steady state, because I noticed there was still little transient inflows around 1900. And then you also need to point to the base map. And so when you copy everything over, you're going to need to change your base map directory probably. But if we go to model, no, plot map overlays, you'll see that right now I'm only drawing counties up, and maps county.map is what this is pointed to. So you're going to need to grab this file as well, or be able to point to it. Otherwise, you're going to see this model, but you're not going to have the Illinois boundary, the Illinois counties on there. So and you may just have to copy that over to your machine and then readjust that directory. It'll actually say, I can't find this file. Where is it? And then you can say, oh, well, it's here on my machine at this location. So there's two things that you need then. A few things you need. You need access to this folder, update to model, and you're going to need, I think. Well, why don't I just leave it up on the screen rather than writing it up? So before you leave, make sure you get access to this folder. And then the other folder you needed access to is this up to date. And the other folder you're going to need access to was Groundwater 2016. This folder, which has our base map that you're going to need. Okay, and then I just need to share this with basically before you head out, just type your name into this. You know what? Why don't I just make this really easy? I'll delete it later, but you can just grab everything in this folder. You don't need the other files because when you hit run, it'll write all the files. So
do you need to make sure that it's pointed to, shouldn't, because it's going to run on a groundwater system that's installed. Just want to make sure, do you need to have the model pointed to an executable file or anything like that?
should have that handled. Okay. But when you run it, if it's not pointed to the right executable file, it's going to get me. I can show you where
I'm
that is.
sure we can figure that out.
Yeah.
Just thinking things through that could go wrong.
Yeah. Yeah, it could be that that'll be a little trick. But again, the model executable files are under model paths to models. And so we're running this unstructured grid Win32. So I guess if your Groundwater Vista 7 is on your C drive, you should be in good shape. And let's see. Other than that, I'd say just have some fun with it. Let me know if you have any questions with it. It'll be, oh, I should show you quickly how to run the model then. And I can do that right now. It takes a little while. But what you're going to do once you get it open, once you save it, well, copy it over, you don't need to save it. Unless you've changed any directories. Once you've changed directories, make sure you save it. You don't have to do that time and again. Just hit recalculate, and that's going to do everything for you. It's going to write, well, it gives you the option. Do you want to write the files first? If you copied all the files over, you wouldn't necessarily have to rewrite them. I was going to recommend rewriting. Hit yes. Go wander around for about 20 minutes because it takes a long time to write the files. They're writing over here on this other screen, but you'll see this for about 20 minutes. And then after it's done, it'll basically say, there's an error file. Do you want to view that? Go ahead and view it. It's probably going to be boring. It should be anyway. Shouldn't have any errors. And then at that point, it'll give you the option to run the model. You just say, yeah. Then it'll be off and running. And it'll eat up about 1/10 of your available hard drive space. Maybe it won't be quite that large, but it'll eat up a substantial portion of it.
So as it sits right now, it's set to run for 143 of the 198 test
Yeah.
periods. You want to do that?
Actually, click that off. Let it run out to 2050. Let it run the entire duration. That's a good point. It's going to run overnight. It's going to take, I think it'll be done in the morning. Once you get here at 6 a.m. or something.
So if the model is going to crash or not going to run, it's going to crash like immediately. It's not going to run for 20 minutes or 2 hours and then crash.
Most of the time, that's true. 100% of the time, probably not. I've seen it crash before. The other problem is sometimes your computer will do an update and restart, and you will lose your model that you run. So something to keep in mind. I've got in trouble before though by turning off my updates and then forgetting to turn them back on for 2 months or something. I'll get a call from Doug or Tony. Why is your model not, or why is your computer not updated? Oh, so I think they finally made it to where I can't turn it off. I don't know if that's possible or not, but they don't trust me with that. This computer, I'm pretty sure, never restarts, and probably should do an update on it. We can edit that part out, right?
Sure.
Yeah, so
Great. Thanks, Daniel, for taking us through all of that.
yeah, and then I think tomorrow let's plan on sitting down and talking about the Joliet specific stuff and getting that running. And yeah, you'll need this model on your machine anyway. So I don't think we're going to do any other update. We're just going to put in the new monthly pumpage for the last few months and just do the calibration. But maybe by Wednesday we can start talking about what we do with some outputs and kind of the three main things that we do, which is potentiometric surfaces, hydrographs, and the mass balance by zone, which I think covers everything that we need to do in the near future. Cool. Yeah. And then I think what we'll do, even though it's not perfect, well, we'll get there. Any other questions or anything that?
So to be honest, I missed a lot of your suggestions on how to have a good model run that doesn't crash. Would it be possible for you to put those in an email or?
Yeah, what were they again? The suggestions for?
It was in reference to Alan's question about things you should do to ensure a good model run. Is that?
Well, no, just making sure that we have enough to begin clicking and poking around and prodding the model, and not having silly errors that that would prevent us from having a complete model run.
I
talked
gotcha.
about making sure the
I
paths
gotcha.
are in the right spots. He talked about.
I think the best thing though, right now, if you want to just try getting copy it over and just try getting it running before the end of the day,
Okay.
then just come grab me if it's not behaving. There'll probably be little bugs or something, but we can walk through those pretty quickly, I think. So yeah, so I'll recommend that you just add yourselves with read permission here to this folder, and then from there just go ahead and copy it over and see how it behaves. See if you can get it running. It's still churning and burning slowly here.
Thanks, Daniel.